Hello students, today I am here to teach you chapter 27 in your textbook that's called Chords of a Circle. So we'll see what are chords. You have started circles in grade 6. So today you are learning more about circles. So let's take a circle. What you call this point? We call it center. What's the line joining from the center to any point on the circle? We call it radius. What's the letter we use for radius? We used simple R. Now we'll take another circle. So here, if we join any 2 points on the circle but passing through the center, what you call that? Any line passing through the center? We call it diameter. So we use the letter D. We'll take another circle. What you call this outer length? We call it circumference. And we use the letter C for that. Now, today we are learning about chords. What's a chord? So, chord is a line segment joining 2 points on a circle, but not passing through the center. So, here I'll draw 2 chords like this. So, these are chords. So, we'll see what are the properties in chords. Now, we'll take this circle and then I want to draw a chord AB. Let's say AB is 12 centimeters. That means here to here the length is 12 centimeters. And if I say I want to take the midpoint of the chord, so what is midpoint means? Dividing this chord into 2 equal parts. So if I take P as the midpoint, we know that. What's the distance of AP? AP is equal to 12 divided by 2 because equally divide this into 2 parts. That's become 6 centimeters. What about PB then? PB also same length. Now we'll take another one. Again we'll take any chord AB. Here, if this is the center, we'll take as O. I want to connect this center with the midpoint of this chord AB. So, P is the midpoint. So, I want to connect. So, what you call this line? This is the line joining with the center and the midpoint of the chord. So here we can write what is OP. OP is the line joining center to the midpoint of the chord. AB. Now we'll take another circle. Again we'll draw chord C, D or something. This is the center O. Now when you connect midpoint of this chord CD, we'll take as a E or something. There's a property here. This line and this line becomes perpendicular. So we'll see how we can show that with the formal proof. So here there's a property. When you join the center with the midpoint of the chord, is always perpendicular to the chord. So here we can write OE is perpendicular to CD. So here these are all about chords. Now we'll look at the theorem number 1 related to chords. It says the straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. So here they want to show that when you take the center O and if the chord is AB, the straight line joining the center to the midpoint. So here we'll take P as the midpoint. This line is perpendicular to the chord. So we need to show this is 90 degrees. So here what we know about this circle, we know O is the center and AB is the chord and P is the midpoint. So what you need to prove? We need to prove that OP line is perpendicular to AB. Now we need to do a small construction. So what we need to do? Just join OA and OB. Join OA and OB. Now we'll see how we can prove this. So the formal proof of this theorem, here we have to take these two triangles OAP and OPB triangle. When you take these two triangles, what you know about those two? We know AP is equal to PB. Why? What's the reason? P is the midpoint. Then we know OP is same as OP. That's the common length, common side. And what else we know? What are OA and OB? Those are radii from the same circle. So those are equal. So OA is equal to OB radii from the same circle. So what can we say about these two triangles? Side, side, side. So these two triangles are congruent. So therefore, OAP triangle is congruent to OPB triangle. What's the reason? Side, side, side. So, when they are congruent, what are the other elements that are equal? Corresponding elements that are equal. When you take these two triangles, we can say that this angle, opposite to this line is this angle, is same as this angle. So here, therefore, we can say OPA angle is equal to OPB congruent elements. If these two are equal, what can you say? So this is, put x and x here. So 2x, x plus x. So this is a straight line. So straight angle you are getting. So we can say 2x equals 180. So what is x? X equals 90 degrees. So 90 degrees means this line is perpendicular to AB. So we can, therefore we can say OP line is perpendicular to AB. So that's how we can prove the theorem number 1. So what it says, when you connect the center with the midpoint of the chord, it's always perpendicular to the chord. Now we'll try to apply this theorem in several situations. In your textbook, example number 1, it says AB is a chord of a circle with center O. So we'll try to draw that. So it says AB is a chord. So I can draw any line with AB. Center O. So mark O. Radius is 5 centimeters. So that means this length is 5 centimeters. So here also 5 centimeters. The midpoint of AB is C. So here when you equally divide this one, that's C point. If AB is 8, so given that AB is 8 centimeters, find the length of OC. So you are asked to find this length. So how can we use the theorem number 1? So here this is the midpoint and this is the line joining the center with the midpoint of the chord. So we know that this is perpendicular according to the theorem number 1. If this is perpendicular, we get a right angle triangle. So, and also we know C is the midpoint. So what is the length of AC? We can straight away write AC length is 8 divided by 2, 4 centimeters here. So we know this is 4 centimeters. Now we'll take this triangle. We get a right angle triangle OAC. This length is 4 centimeters and this is 5 centimeters. Now you are asked to find out the length of OC. So we'll put X there. So what can we apply? Think about carefully. What's the rule we can use? This is a right angle triangle. So we can use Pythagoras theorem. So when you are using Pythagoras theorem, what can you say? This is the hypotenuse. OA is the hypotenuse. So hypotenuse squared is equal to the sum of square terms of the other sides. 4 squared plus x squared. So now try to simplify this. 5 squared is 25. 4 squared is 16. So when you take 16 to the other side, what is x squared? 25 minus 16, you get 9. What is the square root of 9? That's a perfect square. Take the square root. You get plus or minus 3. But this is about length, so you can't take the negative value. So we can say the OC length should be 3 centimeters. Now we'll see the next example in your textbook. So here it's also given, there's a circle. So we'll take this circle. PQ is a chord. So you know what is a chord? So you can straight away draw PQ chord. And O is the center. And the midpoint of PQ is R. So here we'll take R and this is equally divided because it's the midpoint. If QOR is 40 degrees. So here it's given this angle is 40 degrees. Find OPR. This angle. So we'll say this is X. How we can do this? So this is also about a chord. This line is the line joining the center with the midpoint of the chord. So we know that this is perpendicular. So this is 90 degrees. If you know this is 90 degrees, how can we find out this angle? So this angle is the same as this angle. Why? What's the reason? We know this length is equal to this length. So we can write OP length should be equal to OQ. That's the radii of the same circle. So if you know this, think about OPQ triangle. OPQ triangle should be an isosceles triangle because these two sides are equal. So that's an isosceles triangle. So here, if this is X, this also is equal to X. So look at the small triangle and we can use the sum of angles in the triangle. So when you look at OQR triangle, we can say 90 plus 40 plus X is equal to 180. What's that? What's the theorem? The sum of angles in a triangle. Sum of angles in a triangle. So now try to solve for X. 90 plus 40, 130 equals 180. So X is equal to 180 minus 130. We can straight away write down that's 50 degrees. So what's the angle of OPR? That's equal to 50 degrees. Let's take the exercise number 27.1 and the first question. Find the value of X in each of the following figures using the given data. In each figure, O is the center of the circle. Now look at the diagram carefully. XY is a chord and O is the center. And here can you see these two lengths are equal means Z is the midpoint of XY. So that means according to theorem number 1, we know that this is 90 degrees. OZ is perpendicular to XY because of the theorem number 1. One about chords. If you know this is 90 degrees, now think about OZY triangle. What can you say about angles? X plus 90 plus 30 degrees is equal to 180. That's a triangle. The sum of angles in a triangle is 180. So when you solve this, x plus 90 plus 30 is 120 is equal to 180. X becomes, take 120 to the other side, 180 minus 120, you get 60 degrees. Now we'll take the second part. So here look at the diagram carefully. AB is a chord, O is the center, and C is the midpoint of AB chord. So here definitely we can, first thing we can say OC is perpendicular to AB. What's the reason? Theorem number 1. The line joining from the center to the midpoint of the chord is perpendicular to the chord. Theorem 1 related to chords. And also look at this triangle. AC is given equal to OC. So that means that's an isosceles triangle. OAC is an isosceles triangle. So we know if it's an isosceles triangle, the corresponding angles are equal. So if this is x, this is also x. Now we can use the sum of angles in a triangle. When you look at OAC triangle, what can we say? We can write x plus 90 degrees is equal to 180 because the sum of angles in a triangle is 180 degrees. Then try to solve. X and x becomes 2x plus 90 is 180. So take 90 to the other side. 2x becomes 180 minus 90. So you get 90 there. If 2x is 90, so how we can find x? X is equal to 90 divided by 2. That means 45 degrees. Now let's take the third part. Again, look at carefully. So PQ is a chord, O is the center. And this line, OS line, is the line joining the center and the midpoint of the chord. So straight away, what can you say? We can easily write this should be perpendicular. So here OS line should be perpendicular to PQ chord. That's theorem number 1 related to chords. And also look at carefully. We see OP and OS lengths are equal. Why? What's the reason? Radii. So here radii of the same circle. OP is equal to OS radii from the same circle. Now here when you look at this triangle, what can you say? This is an isosceles triangle. So here OPS angle is also 55 degrees. This angle is also 55. Now we'll take this one as y. Okay, if you take this one as y, we can easily find out this y value. How? We know when you take PS. So here there's no letter here. When you take the smaller triangle, we can write y plus 90 plus 55 is equal to 180. So that's this smaller triangle. The angle sum of a triangle is 180. So when you simplify this, y plus 145 is equal to 180. Y equals 180 minus 145. So what's 180 minus 145? 35 degrees. We know this is 35 degrees, but the full angle we found out, that's 55. So how can we find x? So we can easily find out x plus y. We found that's 55 before, but y is now 35. So plug the value there and subtract. So x is equal to 55 minus 35. What's the answer? 20 degrees. So this value becomes 20 degrees. Now we'll take the fourth part. So when you look at the diagram, again we can see AB is a chord and X is the midpoint and O is the center. Now when you look at carefully, we know that this is perpendicular to each other because this is the center with the midpoint. Here also when you look at this chord, BC chord, this is center with the midpoint. So that's also 90 degrees. So straight away, according to theorem number 1, you can write OXB angle is 90 degrees as well as OYB angle is 90 degrees. What's the reason? Chords, we can write according to theorem number 1 related to chords. Now look at carefully. What is OXBY? That's a quadrilateral. So when you look at OXBY quadrilateral, we know the sum of angles in a quadrilateral is 360. So here we can write 90 plus 110 plus another 90 plus x becomes 360. That's the sum of angles in a quadrilateral. Now try to simplify. So when you add all these together, what do you get? 290 plus x is 360. So what is x value? Take 290 to the other side and subtract. So you get 70 degrees for the x value. Now we'll take the fifth part. Again we can see AB is a chord, AC is a chord and O is the center. So here straight away, according to theorem number 1, we can say that these all are 90 degrees because the line joining the center with the midpoint of the chord is perpendicular to the chord. So, what can you say about O, P, A, Q quadrilateral? So, we can say the sum of angles in a quadrilateral is equal to 360. So, 45 plus 90 plus x plus 90 is equal to 360. So, sum of angles in a quadrilateral. So, try to simplify this. So, when you add all together, you get 9, 9, 18. 18 plus 4, 22. So, 225 plus x is equal to 360. So, what is x? X becomes 360 minus 225. So, when you subtract, what you get? 5, 10. So, you get 3, 6 minus 3, 3, 3 minus 2 is 1. 135 as this angle. Now we'll look at the next part. This is about a circle and PQ is a chord, QR is a chord. And given that X is the midpoint of PQ chord and Y is the midpoint of QR chord. So straight away we can take these two angles are 90 degrees because the line joining the center with the midpoint of the chord is perpendicular to the chord. So when you look at the diagram again, OXQY quadrilateral, we can straight away write 90 plus 60 plus 90 plus x is equal to 360. What's the reason? The sum of angles in a quadrilateral. So try to simplify this. When you add, you get 240 plus x is 360. So how can we find x? 360 minus 240. You get 120. Now we'll move to the next question. Now it says PQ is a chord and the center is O. The midpoint of the chord is R. So if this is the midpoint, you can straight away mark these are PR is equal to RQ. So the whole length is 12 centimeters and OR. So OR length is given 8 centimeters. Find the radius of the circle. So here we'll draw this line. So you need to find out the OP length. And also we know PQ length is, what's the length? 12 centimeters. So what is PR length? If this R is the midpoint, so you can divide by 2 and get 6 centimeters for PR. And also according to theorem number 1, PQ and OR are perpendicular to each other. So here OR is perpendicular to PQ. That's theorem number 1. About chords. So here we know that this is a right angle triangle now. This is 90 degrees now. It's perpendicular. So if this is 90 and this is 6 centimeters, this is 8 centimeters, you are asked to find out this length. So this is about a right angle triangle and you have to find one length and the other two lengths are given. So what's the theorem we can use? We can use Pythagoras theorem. So according to Pythagoras theorem, it says the hypotenuse squared is equal to the sum of square terms of the other two sides. So when you simplify, 6 squared is 36, 8 squared is 64, 36 plus 64 is 100. So square root of 100. You get plus or minus 10, but this is about length, so you take the plus value. So 10 centimeters, because the units given in centimeters. So we know the radius of this circle is 10 centimeters. Now we'll look at the third question. It says AB and BC are chords of a circle with center O, which are perpendicular to each other. So this line AB and BC, given that, that's 90 degrees. And also the midpoint of AB and BC are X and Y. So when these are midpoints, I can mark like this. And here it's not given two equal, so you can put these lengths are also equal. And then you're asked to find out the perimeter of the quadrilateral OXBY. So that means you have to find out the lengths. So we know AB is 12 centimeters. So what's the length of XB? Half of it, because X is the midpoint. So here you can divide by 2 and get 6 centimeters. So this is 6 centimeters. And also, what about BC? BC length is given 8 centimeters. So that means you can straight away find out BY, that's half of that, 4 centimeters. So here this is 4 centimeters, this is 6 centimeters. And according to the theorem number 1, what you know? This one is perpendicular to each other. This is also perpendicular. So what you get here? 90, 90, 90, 90 with different lengths. That's a rectangle. So here straight away we can write down OXBY is a rectangle. So if this is 6, this is also 6 centimeters, this is 4 centimeters. Opposite sides are equal in a rectangle. So you can, what's the perimeter? So perimeter of OXBY is equal to, just add all lengths. Perimeter is the outer length of a figure. So 6 plus 4 plus 6 plus 4. So what you get? 10, 10 plus 10, 20 centimeters. So the perimeter of the quadrilateral given is 20 centimeters. Now we'll take the fourth question. In the fourth question, it says AB and BC are two chords. So these are two chords and center is O, and also both are perpendicular. So AB and BC are perpendicular. So that means it's given, this is 90. Here perpendicular means this angle is 90 degrees. The midpoints of AB is X and midpoint of BC is Y. So already marked with equal lengths. If AB is 8 centimeters, so AB is given 8 centimeters and BC, this length is given 6 centimeters. Find the perimeter of the quadrilateral BX or Y. So this is similar question to the question number 3. So you are asked to find out. Now we found this is 90. And what else we can find out? We know D is also perpendicular. According to theorem number 1, OX is perpendicular to AB and OY perpendicular to BC. So both are related to theorem number 1 in chords. So here that means OX BY is a rectangle. Now we know AB is 8. That means what is BX? BX is 8 divided by 2. That's 4 centimeter because X is the midpoint of AB. We know BC is 6. So what is BY? 6 divided by 2, that's 3 centimeters. So here we know this is 3 centimeters, this is 4 centimeters. So what's the perimeter of the rectangle? So the perimeter becomes 4 plus 3 multiplied by 2, or you are just adding 4 plus 3 plus 4 plus 3. So I'll do 2 times 4 plus 3. 4 plus 3 is 7. 7 times 2, 14 centimeters. Now we'll look at fifth question. So the vertices P, Q and R of the triangle PQR lie on a circle with center O. The midpoints of PQ and QR are given A and B. So already marked there. PQ is 16. So PQ is 16 centimeters. So straight away you can write OA is half of 16. That's 8 centimeters. OA is given 6 centimeters. So this is 6 centimeters and this is AQ. This is not OA. Midpoint of PQ is A. So AQ. So here QA is 8 centimeters. And again it's given OB is square root 19. This is square root of 19. And you are asked to find out the length of QR. So here when you look at the diagram, we know A and B are midpoints of those chords. So straight away we can write these two angles are 90 degrees because OA is perpendicular to PQ as well as OB is perpendicular to QR. So this is according to theorem number 1 related to chords. Now here when you draw a line here, when you connect OQ length, you get two right angle triangles. Now we'll draw the first triangle, right angle triangle. You get A is 90 degrees, OQ. So OQ, we don't know the length, and AQ is 8 centimeters, OA is 6 centimeters. Now we can find out the OQ length. So we'll put X here. So this is a right angle triangle and you can use Pythagoras theorem. So according to Pythagoras, we can say x squared is equal to 8 squared plus 6 squared. So according to Pythagoras. So here 8 squared is 64, 6 squared is 36. When you add, you get 100. Square root of 100 is 10 centimeters. So we found OQ is 10 centimeters. Now look at the other triangle. Now when you draw the other triangle, This is OQ. Now we already found this is 10 centimeters. So we know OB is square root of 19. And we need to find out the length of BQ. Why? We need BQ because they are asking to find out the length of QR. So the length of QR is double of BQ because B is the midpoint of the chord. So we'll put Y for this length. Again, we know this is 90 degrees. Use Pythagoras theorem again. Hypotenuse squared is equal to sum of squares of the other two terms. What is square root of 19 square? So square root and square term get cancelled out and you get 19. So you get 100 here, y squared plus 19. Y squared is 100 minus 19. You get 81. So what's the y value? Y value is the square root of 81 is 9 centimeters. So here we found that BQ length is 9 centimeters. So if BQ is 9 centimeters, so what is the QR length? Double of that. So 2 times 9 centimeters, so you get 18 centimeters for the length of QR. Now we'll look at examples in your textbook. So here you are given a circle with AB and CD are chords and O is the center, and also given the midpoints of these chords are X and Y. So that means straight away you can write down this length is equal to this length, this one is equal to this length because X and Y are midpoints. And you are asked to show that OX is equal to OY. So here you have to prove that. So to be proved, OX is equal to OY. So here we have to look at the two triangles. So what are the two triangles we need to look? OYC triangle and OBX triangle. What you know about those two triangles? We know this is perpendicular. The line joining the center with the midpoint of the chord is perpendicular to the chord. So straight away you can write OY is perpendicular to OX. OY is perpendicular to DC and OX perpendicular to AB. And we can see these two are right angle triangles. So here OYC angle is same as OXB angle, that's 90 degrees. And also we know this length, OC length is equal to OB. What are those? So when you take this circle, OC and OB are radii. So here radii of the same circle. So I can write this length is equal to this length. And also we know these are equal chords. Equal chords means I don't need to take different lengths. So here AX, I can write XB should be equal to YC. Why? What's the reason? Because it's given DC is equal to AB, and when you take half of it, both sides, you get XB and YC. So those two lengths are equal. So now I don't need to write down with a different lengths. So I can write these all are equal. So here we know that one angle and two lengths are equal. So here we can see these two are congruent to each other. So what's the reason? OYC triangle is congruent to OBX triangle. So here we can see this is the hypotenuse. Hypotenuse are equal and one side equal. So in a right angle triangle, hypotenuse and one side equals, we call RHS. So these two triangles are congruent. Then what can you say about corresponding elements? So OX and OY are corresponding lengths. So here straight away you can write OY is equal to OX because corresponding elements of a congruent triangle. So that's how you show OX equals OY. Now we'll take example number 2. So it says S is the midpoint of the chord, already marked there, and center O. OS produced meets the circle at R if R is equal SO. R is equals SO. Show that OPRQ is a rhombus. So here you are asked to show this is a rhombus. So what's the rule we can apply? Now here it's already given. PS is equal to SQ because S is the midpoint. And also it's given SR equals OS. Already given. So here, if you take this OPRQ quadrilateral, what can you say about that quadrilateral? The diagonals bisect each other. So here in OPRQ quadrilateral, we see diagonals bisect each other. And also when you look at the diagram, what can you say about OR line and PQR line? Here S is the midpoint and O is the center. When you draw the line from the center to the midpoint of the chord, that's perpendicular to the chord. So here we can see that this is 90 degrees. So here we can see PS is perpendicular to OR according to theorem number 1 related to chords. So here we see diagonals bisect at 90 degrees. So therefore diagonals bisects at 90 degrees. So what can you say about diagonals bisect each other as well as bisects at 90 degrees? So when you look at this property, what can you say about the PRQ quadrilateral? We can say this is a rhombus. So here with these two diagonals bisect each other as well as diagonals bisect at 90 degrees, we can say OPRQ is a rhombus. Now we'll look at exercise 27.2 in your textbook, and the first question, it says R is the midpoint of PQ chord and O is the center. ROQ is 45. We'll mark this ROQ. So that means this angle is given 45. Show that RQ is equal to OR. Okay, so we'll try to do that. Now this is about a chord and this is the midpoint. We can straight away take OR is perpendicular to PQ. So this is 90 degrees. If this is 90 degrees, what can you say about this triangle? ORQ triangle. We can say the sum of angles in a triangle is 180. So 45 plus 90 plus OQR angle should be equal to 180. The sum of angles in a triangle. So when you simplify this, you get 135 plus OQR triangle is 180. So what is OQR angle? 180 minus 135, you get 45. So we found this is also 45. Now look at carefully. This angle is 45 and also this is 45. You get an isosceles triangle. So this is 45, this is 45. So we can say this length is equal to this length. So here ORQ is an isosceles triangle. So what you know about isosceles triangle? We know corresponding lengths also equal. So we can say QR or RQ is equal to OR because corresponding lengths of an isosceles triangle. So that's what you need to prove. RQ is equal to OR. Now we'll take question number 2. So it says AB is a chord and O is the center and C is the midpoint, already marked with equal lines. And when OC is produced meet the circle at D, show that AD equals DB. So that means we have to connect AD and DB. So we need to check whether these two are equal. So again, we can use the two triangles and see. So we'll take ACD triangle and CDB triangle. What you know about those two triangles? We know AC is equal to CB, already given. C is the midpoint. And CD is common side. What you know about this angle? We know this is perpendicular. Angle is 90 degrees. So we can write ACD angle and DCB angle. Both are 90 degrees. That's according to theorem number 1 related to chords. So here when you look at these two triangles, one angle and two lengths, and also this angle is the included angle. Included angle to these two equal lengths. So that means these two triangles are congruent. So we can write ACD triangle is congruent to BCD triangle. What's the situation? It's a side angle side. So if these two are congruent, what can you say about corresponding elements? So corresponding elements are equal. So when you look at AD and DB, both are equal because those are corresponding elements of the congruent triangles. So here that's what you have to prove. Now we'll look at question number 3. The vertices ABC of the triangle ABC lie on a circle with center O. The midpoint of BC is given X. If O lies on AX, the center lies on AX, show that AB is equal to AC. So here again we need to look at the two triangles. So here we'll try to prove that. We'll take first ACX triangle and AXB triangle. What you know about those? We know AX is common length. And also we know CX is equal to XB because X is the midpoint. What else we know? We know this is passing through the center means the OX is perpendicular to BC. So what can you say about the angle? We can say AXC angle and AXB angle both are 90 degrees according to theorem 1 in chords. So these two lengths and this is also included angle. So what can you say about two triangles? Two triangles are congruent. So we can straight away write down ACX triangle is congruent to AXB triangle. What's the situation? Side angle side. An angle is the included angle to these two lengths. So we can straight away, these two are congruent. So what about the corresponding elements? Corresponding elements are also equal. So we can write down AC is equal to AB. What's the reason? Corresponding elements of a congruent about two triangles, corresponding elements of congruent triangles. So we prove that AB should be equal to AC. Now we'll see the fourth question. So it says PQ and QR are two chords of a circle with center O which are perpendicular to each other. So here PQ and QR, both are perpendicular. The midpoint of PQ and QR are X and Y. So these two are midpoints. Show that OXQY is a rectangle. So we did a similar question to this before. So how can we show that this is a rectangle? So that means we have to show all these angles are 90 degrees. So when you look at the circle, we know that OX is perpendicular to PQ. That means this is 90 degrees. And also we see OY is perpendicular to QR. According to theorem number 1, we did in this lesson. So here we found that this is 90, and definitely if this is 90 and this is 90, the sum of angles in a quadrilateral is 360, so this is also 90 degrees. Now we found out all angles are 90 degree each and the two lengths are different. So what can you say about this quadrilateral? It's a rectangle. So here we can say all angles in the quadrilateral are equal to 90 degrees. So therefore we can say OXQY is a rectangle. So we'll move to the next question. So in question number 5, it says AB and CD are two chords. This is AB and CD are two chords of a circle with center O. The midpoints of AB and CD given as P and Q. The chords AB and DC produce meet at M. Show that POQ, this angle, and PMQ, this angle are supplementary angles. What is supplementary means? Supplementary means add up to 180 degrees. So here we have to show that. So what we need to show to be proved? POQ angle plus BMC angle should be equal to 180. Now, what are the information given here? This is about chords. So straight away you can say this is 90 degrees and this is also 90 degrees. So we'll write that OP is perpendicular to AB, OQ is perpendicular to CD. Theorem number 1 about chords. So can you remember the theorem? The line joining the center to the midpoint of the chord is always perpendicular to the chord. So these are perpendicular, so you can straight away write down OPM angle and OQM angle, both are 90 degrees. So if these are 90 degree, now think about the quadrilateral OPMQ. We know the sum of angles in a quadrilateral is 360. So we can write down 90 plus POQ angle plus 90 degrees again, this one, plus PMQ angle, that should be equal to 360. Now try to simplify. 90 and 90 becomes 180. So 180 plus POQ angle plus PMQ. PMQ triangle angle PMQ. PMQ is same as this angle, is equal to 360. So take 180 to the other side. We can straight away write down POQ plus PMQ is 360 minus 180 becomes 180. So here we found these two angles add up to 180. 180 means those are supplementary. Now we'll look at question number 6. It says the midpoint of the chords AB, this one is given as P and center is O, and the other midpoint given as Q. Show that POQ, so we'll see what's POQ, this angle, is equal to BAC. BAC, this angle plus ACB. ACB, this angle, so you have to show this angle is equal to the sum of the other two angles. So here again, this is about chords. You can straight away write down, this is 90 degrees. OP perpendicular to AB as well as OQ perpendicular to BC related to theorem number 1 about chords. And then what can you say about this one? So here we'll take this one. When you take this side in the OPBQ quadrilateral, we can write the sum of angles in a quadrilateral is 360. So we can write POQ angle plus 90 plus 90 plus ABC angle is equal to 360. So when you take 90 and 90 becomes 180, and when you take it to the other side, what can you say? POQ plus ABC angle is 360 minus 180, that's equal to 180. We'll take this one as 1. Now when you look at the triangle ABC, what can you say? When you take ABC triangle, we know that the three angles add up to 180. So BAC angle plus ACB angle plus ABC, that's equal to 180 because sum of angles in a triangle. Now here, what can you say about ABC now? Here, we'll take this one to the other side, or you can just equate. Here, both are equal. So this is equation number 2. So according to 1 and 2, both sides are equal. We can write POQ plus ABC, this side, is equal to BAC plus ACB and ABC. Now can you see ABC in both sides you can subtract. So when you subtract these two, what you get? POQ is equal to BAC plus ACB. So that's what we need to prove. Now we'll look at the 7th question. It says PQ and RS are two equal chords. PQ. Equal chords means when you look at the midpoints also, the lengths are equal. So X and Y are midpoints, and show that XPS, this angle is equal to YSP, So you have to show these two are equal. So first thing we can do, look at this diagram. You can straight away write down OX perpendicular to PQ, because this is the chord and the line joining the midpoint and the center. And also OY is perpendicular to SR. Both are perpendicular because of the theorem 1. So we can write, so this is 90 degrees. Okay, so here if you know this is 90 degrees, what can you say about the lengths? We know PQ is equal to SR. It's given because it's two equal chords. So when you take half of this, you get this length and this length. Both are equal. So we can straight away write down PX is equal to SY, because X and Y are midpoints. Now we know these two lengths are equal. So here now we'll look at these two triangles and see. So we'll take PXO triangle, and OSY triangle. What do you know about those two triangles? We know PX is equal to SY, because those are midpoints. And also we know that this angle is 90 degrees. So here PXO angle is equal to SYO angle, that's equal to 90 degrees. So this is about a right angle triangle and one length is equal. And what you know about these two lengths? So those are equal. Why? What's the reason? Those are radii of the same circle. So OP is equal to OS, radii of the same circle. So here, this is a right angle triangle and hypotenuse are equal and one length is equal. So these two are congruent. What's the case? We can say in a right angle triangle, hypotenuse and side, RHS. So these two are congruent means we can straight away write down the corresponding elements. So the corresponding elements means this angle is equal to this angle. So we can write down XPO angle is equal to OSY angle. What's the reason? Corresponding elements of a congruent triangle. And also, when you take OPS triangle, these two lengths are equal, means this angle is equal to this angle. So here we can write down OPS angle is equal to OSP angle, because OPS is an isosceles triangle. So we can write, because OP is equal to OS and this is an isosceles triangle. Now if it's equal, now we'll take this one as 2 and this one as 1, this equation as 1. We'll try to add these two. So when you add 1 and 2, what you get? OPS, this angle plus XPO, this angle. What you get when you are adding? You get the full angle XPS. When you do the same thing for the right hand side, OSY, this angle and PSO angle, what you get? You get PSY or YSP angle. So these are YSP angles. So these are definitely equal. Now we'll look at theorem number 2. So that's the converse of theorem number 1. So what is theorem number 1? We said the line joining the center to the midpoint of the chord is perpendicular to the chord. Now the converse is the perpendicular drawn from the center of the circle to a chord bisects the chord. So we'll take this theorem and try to prove. So here I'll take a circle. So what it says here? It says the center is O and there's a chord, and when you draw the perpendicular to the chord, we'll take this one as AB, this is the perpendicular, that's 90-degree angle, and we have to check whether these two lengths are equal. Bisect the chord means, so this, if it's C is the midpoint, AC should be equal to CB. Now we'll try to prove that. So here what you need to prove? We need to show that AC is equal to CB. What you know? We know O is the center and OC is perpendicular to AB. So that means this is 90 degrees. We already know that. And we'll take these two triangles because we need to show that AC is equal to CB. So when you take OAC triangle and OBC triangle, what can you say? We know that OC is common. And what else we know? We know this is equal to this one. What's that? Those are radii of the same circle. So OA is equal to OB. Those are radii of the same circle. And we know this angle is 90 degrees. OCA angle is equal to OCB angle, that's 90 degrees. Because we have drawn the perpendicular to the chord. So here when you look at these two lengths and this one, what you get? This is a right angle triangle because this is 90-degree angle, and the hypotenuse and one side equal. So what can you say about these two triangles? These two triangles are congruent. So therefore we can say OAC triangle is congruent to AOBC triangle. What's the reason? Right, in a right angle triangle, the hypotenuse and one side equal. So if these two are congruent, what can you say about the corresponding elements? Corresponding elements are equal. So that means AC is equal to CB. So if these two are equal means the chord bisects. So therefore the chord bisects. So what's the converse of the theorem 1? It says when you draw a perpendicular from the center to the chord bisects each other. So here this theorem is the converse of theorem number 1. Now we'll try to use this theorem in exercises and examples. So here in your textbook, the example 1. So it says AB and BC are two equal chords. So here AB and BC, two equal chords and with the center O. The perpendicular drawn from O to two chords are OX and OY. So here it already marked. So these are perpendicular. So XBY is 70 degrees. Then find the magnitude of BXY. BXY. So you are asked to find out this angle. So we'll try to find out. So what you know about converse theorem? Converse theorem said when you draw a perpendicular, the chord bisects. So here, and also it's given BC and AB are equal chords. So definitely all these lengths are equal. Half of, when you divide by 2 both sides, you can see that BX is equal to BY. Now when you look at this triangle, BYX triangle, what can you say? Two lengths are equal, you get an isosceles triangle. So here it's an isosceles triangle. So if this angle is this one, so that's equal to BYX angle because the corresponding angles are equal. So here we can write if this is X, this is also X. So when you look at the triangle, we can write X plus 70 is 180. Sum of angles in a triangle. And then 2x plus 70 equals 180. 2x becomes, take 70 to the other side, 180 minus 70, you get 110. So when you divide by 2, you get x equals 55 degrees. So here that means BXY angle is 55 degrees. Now we'll look at example number 2. So here in this example it says OR is the perpendicular drawn from the circle with the center O to the chord PQ. And the OR given 3 centimeters. So this is given 3 centimeters and PQ. This whole thing is given 8 centimeters. Find the radius of the circle. So according to the Converse theorem, we know when you draw a perpendicular from the center to the chord bisects. So that means these two lengths are equal. So PR is equal to RQ by a Converse theorem. So here when you look at PQ length, it's 8 centimeters. So half of it becomes PR. So 8 divided by 2, you get 4 centimeters. Now look at the triangle POR triangle. What you know? We know this is a right angle triangle and this is 4 centimeters and this is 3 centimeters. So here you are asked to find out the radius. So radius is OP. So put X here and find out what is the X value. So this is a right angle triangle. You can use Pythagoras theorem. So what's the Pythagoras theorem says? The hypotenuse squared is equal to sum of square terms of the other two sides. So when you do that, 4 squared is 16, 3 squared is 9, 16 plus 9, 25, square root of 25 becomes 5 centimeters. So here we found that OP is the radius of the circle. So the radius is equal to 5 centimeters. Now we'll look at exercise 27.3. So question number, it says ABC is an equilateral triangle. What's an equilateral triangle? All sides are equal. So we can straight away mark all these sides are equal. And what else we know? We know all angles are 60 degrees. And it's given O is the center. The perpendicular drawn from O to BC is OX. And if XB is 6 centimeters, find the perimeter of the triangle ABC. So to find out the perimeter, you need to find out one length and then multiply by 3 because this is an equilateral triangle. So here if XB is 6 centimeters, so here according to the Converse theorem, when you draw a perpendicular from the center, this is bisects each other. So here that means you can find out the whole length of CB is double of that, 2 times 6. So what's the answer? 12 centimeters. Now we know one side is 12 centimeters. So what's the perimeter? So perimeter of the triangle ABC is 12 into 3 because this is an equilateral triangle. So the answer is 36 centimeters. Now we'll look at question number 2. So in this question it's given PQ is a chord and center O and the perpendicular drawn from O to PQ is OR. PQ is 12. So this is given PQ is 12. And OR is 8 centimeters. Find the perimeter of the triangle OPQ. To find out the perimeter, you need to know the lengths. So here what can you say about the PR length? PR length is half of PQ because when you draw a perpendicular from the center to the chord bisects. So when you do that, you can straight away find out PR. That's 12 divided by 2, that's 6 centimeters. So this length is 6 centimeters. Now, this is a right angle triangle. You can use Pythagoras theorem and find out the radius of the circle. So here, use Pythagoras theorem. X squared is equal to 8 squared plus 6 squared. 8 squared is 64. 6 squared is 36. When you add, you get 100. Square root of 100 is 10 centimeters. Now we found out this side is 10. So here we know if this is 10, this is also 10 because those are OP and OQ are radii of the same circle. So here we can write down, so what's the perimeter? Perimeter of OPQ triangle is 10 plus 10 plus, this is 6 and this is 6. So 6 plus 6. So what's the answer? 20, 32. 10 plus 10, 20, 26. 26 plus 6, 32. This is in centimeters. So the answer is 32 centimeters. Now we'll look at third question. So it says PQ is a chord of a circle with center O. The perpendicular drawn from O to PQ is OX, already given. And PQ is 6 centimeters. So here PQ is given 6 centimeters and the radius of the circle is 5 centimeters. So that means OQ or OP, this is 5 centimeter given. Find the length of OX. So you have to find out this length. So here you have given PQ is 6 centimeters. So according to Converse theorem, what can you say about XQ distance? The chord bisects when you draw a perpendicular from the center. So XQ is half of that. So 6 divided by 2, that's 3 centimeters. So we know this is 3 centimeters. So when you look at the triangle OXQ triangle, so this is 5 centimeters and this is XQ is 3 centimeters and you need to find out OX, that's X. So use Pythagoras theorem. 5 squared is the hypotenuse squared is equal to 3 squared plus x squared. Sum of square terms of the other two sides. 3 squared is 9, 5 squared is 25 plus x squared. When you take 9 to the other side, 25 minus 9 becomes 16. So 16 is equal to x squared and x is square root of 16. That's plus or minus 4, but we take the positive value. So you get 4 centimeters. So here we can write OX length is 4 centimeters. Now we'll take fourth question. It says PQ and RS are two parallel chords. So it already marked with arrows and which lie on opposite sides of the center O. The radius of the circle is 10 centimeters. So here we can write from here to here or here to here. That's the radius. So here it's given 10 centimeters. So this is 10 and this is also 10. PQ is 16. So this length is 16 and SR is 12. Find the distance between the two chords. So here you are asked to find out the perpendicular height. So here you are asked to find out this height and this height. So here what can you say about this? According to Converse theorem, when you draw a perpendicular line, the chord bisects. So when you are drawing the perpendicular, we can say this length equally divided as well as this length equally divided. So here, if you know that, you can straight away find out the lengths. So we'll take this triangle, the upper triangle, and find out the height. So here this is the triangle. You know this is 10 centimeters and this is 90 degrees. So 16 is full length. Half of it is 8 centimeters. So you can find out this length using Pythagoras theorem. And also when you look at the other triangle here, this is 10 centimeters given and this is whole thing is 12 and half of it is 6 centimeters. So you can find out this height. So the total of these two heights becomes the distance between the two chords. So here use Pythagoras theorem. You can find 10 squared is equal to 8 squared plus x squared. So what is 10 squared? That becomes 100. 8 squared is 64. And then when you subtract 64 from 100, you get 36. Square root of 36 is 6 centimeters. Now we found out this distance is 6 centimeters. What about this triangle? When you use Pythagoras theorem, you know hypotenuse squared is equal to square of the sum of square terms of the other two lengths. So 10 squared is 100, 6 squared is 36. So when you subtract this, what you get? Y squared is 100 minus 36 becomes 64. Square root of 64 is 8 centimeters. So what's the distance between the two chords? That's equal to x plus y. So we can write down just x is, what's the x value? We found 6 centimeters. What's the y value? 8 centimeters. So the total distance is 14 centimeters. We'll see question number 5. So in question number 5, it says P, Q and R is our two parallel chords of the circle with center O. As shown in the figure, the radius of the circle is 10 centimeters. So how can we draw that? So I can draw here or here. Both are radius. So that's 10 centimeters. PQ is 12. PQ, the whole length is 12 and SR is 16. So this is 16 given. Find the distance between the two chords. So in this case, when you are finding the two distances, you will see this one you can find easily. You can find this total height as well. So if you want the distance between two chords, now you have to take the difference, not the addition. So previous sum, the chords were far away, opposite side of the center. But now the two chords in the same side. So in this case, you have to subtract the two distances to get the difference between two chords. So here we'll try to find out. So we know according to this diagram, O, we'll put this one is X or something, this is Y. OXR triangle, this is 10 centimeters and we know the full length is 16. According to Converse theorem, when you draw a perpendicular from the center, the chord bisects. So that means you can straight away write XR is half of 16, that 8 centimeters. So here we can put the distance, this one is X. When you look at the bigger one, you get 10 centimeter as the radius here. That's OYQ triangle. And what else we know? We know this full length is 12. Half of it is 6 centimeters. So here we'll put Y here. The difference between these two lengths, Y and X, is the distance between the two chords. So we'll try to solve that using Pythagoras theorem. 10 squared is equal to X squared plus 8 squared. 10 squared is 100. 8 squared is 64. And then 100 minus 64, you get 36. When you take the square root of 36, you get 6 centimeters. Now do the same thing for this triangle. Use Pythagoras theorem. 10 squared is equal to Y squared plus 6 squared. 10 squared is 100. 6 squared is 36. When you subtract 100 minus 36, you get 64. So square root of 64 is the Y value. So that becomes 8 centimeters. So what's the distance between the two chords? So the distance between two chords is equal to the difference between the two lengths. So here 8 minus 6, that becomes 2 centimeters. Now we'll look at example 1 in your textbook, and it says AB and BC are two equal chords of a circle with center O. The perpendicular drawn from O to chords are OX and OY. Prove that OX equals OY. Now we'll take a circle and see what we have to prove. So it says AB and BC are two equal chords. So we'll try to draw that. AB and BC, but two equal chords. So here I'll put like this. The perpendicular drawn from O to the two chords. So here draw a perpendicular, that becomes X. Draw a perpendicular there, that becomes Y. Prove that OX equals OY. So here you have to prove this distance is equal to this distance. Now we'll try to use the converse of the theorem. And we'll connect OB. Now what can you say about the two triangles? I can write OXB triangle and OYB triangle. What can you say? When you look at the two triangles, I see OB is the common side. And also, I can write XB equals BY. What's the reason? So here, according to the converse theorem, the chord bisects when you draw a perpendicular from the center. So that means this length is equal to this length. And also, the two chords are equal. So that means this also equal. So that's why these two are equal. So according to converse theorem, these two are equal. And also, can you see this is a right angle triangle? So we can say these two are congruent. So OXB triangle is congruent to OYB triangle. What's the reason? This is a right angle triangle, and hypotenuse and one side equal. So when the two triangles are congruent, we can say that the corresponding elements are also equal. So corresponding elements are OX and OY. So here we can write OX equals OY because corresponding elements are equal. So that's how you prove this. Now we'll look at exercise 27.4 and the first question. So what it says, you have given a diagram. P, Q and R is our two chords of a circle with center O. So center is O. The perpendiculars drawn from O to PQ and RS are OX and OY. Here these are the two perpendiculars. So here also already marked 90 degrees. It says if OX is equal to OY. So here these two lengths are equal. So you are asked to prove that PQ. So what is PQ? This length is equal to RS. So that means basically you are asked to find out the two chords are equal. So here you need to show to be proved PQ is equal to RS. Now what you know from these two triangles, we know when you draw a perpendicular, these two lengths are equal because the chord is bisecting. So here we can write down O, when you look at this one, QX is equal to XP, as well as when you look at this bisector, I'll put another symbol here, RY is equal to YS. Both are equal because of the Converse theorem. And also, what can you say about the lengths? Now I'll draw two lengths OS and OQ. What can you say about those two lengths? Those are equal because radii of the same circle. So again we can say OS is equal to OQ. Radii of the same circle. So we know this is a right angle triangle and hypotenuse and the lengths are equal. And also, can you see from these two triangles, OY is given equal to OX. That's given. Okay, so here we know this is given, and look at these two triangles. These are right angle triangles. So we can say, according to this diagram, OSY triangle is congruent to OQX triangle. What's the reason? Reason is this is a right angle triangle and the hypotenuse and one side are equal. So if these two triangles are congruent, what can you say about the corresponding elements? We can straight away write down SY is equal to QX because these are corresponding elements. So if these are equal, now we'll multiply these by 2. So here SY multiplied by 2 and QX multiplied by 2. So when you multiply by 2, it becomes the whole length of the chord. So here QX multiplied by 2 becomes PQ. When you multiply this by 2, you get the chord SR. So we can straight away write down the chord SR is equal to PQ. Now we'll look at question number 2. So in this diagram it says vertices ABC of the triangle ABC lie on the circle with center O. The perpendiculars drawn from O to AB are O to AB and BC are OX and OY respectively. If AX is equal to CY, so these two lengths are equal, then prove that BAC angle is equal to BCA. So you need to show these two angles are equal. So here what we need to prove? We need to prove BAC angle is equal to BCA angle. Now look at the diagram here. We see, according to Converse theorem, when you draw a perpendicular from the center to the chord bisects. So here that means if this is equal to this one, this is also equal to this one. So here we can write straight away AX is equal to XB, YC is equal to YB according to Converse theorem. But we know these two also equal. So when this is equal to this one, when you multiply by 2, so what can you see? When you multiply this by 2, AB is double of AX, BC is double of YC, and these two are equal. That means we can say AB is equal to BC. When you look at the ABC triangle, these two lengths are equal, means this is an isosceles triangle. So the opposite lengths to those equal angles are equal according to the isosceles triangle. So here we can straight away write down the angle. Therefore, BAC angle is equal to BCA angle. So that's what we need to prove. Now we'll look at the third question. So in the third question it says AB and BC are two equal chords. So here two equal chords given. So AB is equal to BC given. And the center is O, which are perpendicular to each other. So here these chords are perpendicular to each other. It's already marked. Prove that OXBY is a square. So here that means you have to show that all lengths are equal, because we see all angles are 90. The extra property is all sides are equal in a square. So we'll try to show that. Now we know this AB chord is equal to BC chord because two equal chords given. So when you take half of it, because according to the Converse theorem, we know that AY is equal to YB and BX equal to XC. So that's the Converse theorem. Because the chord bisects each other when you draw a perpendicular from the center. So here when you are multiplying by 2, so that means this is equal to this, but as this AB is equal to BC, this is also equal to this one. So what can you say from this diagram? According to this one, we see YB is equal to BX. So how do we know this is also equal? Because this is a quadrilateral with 90-degree angles. So here the opposite lengths are equal either in a rectangle or a square. So this side is equal to this side because opposite sides. So YB is equal to OX as well as BX is equal to OY. So opposite lengths are equal. Now what we can see? All sides are equal. According to this, all sides are equal. So we can say OXBY is a square. Now we'll take the next question. It says AB and AC are two chords of a circle with center O. The perpendicular drawn from O to AC is given OQ, and if 2 times AB is equal to AC, so that means 2 times AB is equal to AC, prove that AB is equal to AQ. So we need to show these two lengths are equal. So here what you need to prove, AB is equal to AQ. Now we'll say this is a chord and this is the center. So here according to this one, so here this is a perpendicular given. We know this is 90 degrees. If this is a perpendicular, we know according to the Converse theorem, this length is equal to this length. So here we can write down OQ according to Converse theorem, AQ is equal to QC. So here this length should be equal to this one according to Converse theorem. So when you multiply this by 2, what you get? QC double, what you get? So here when you multiply by 2, you get AC equals 2 times QC. And also this information is given. So you have given AC is also equals to 2AB. From these two, what can you say? 2 times QC is equal to 2 times AB. 2 get cancelled out when you divide by 2. So you get AB equals QC. So what is QC? QC is same as AQ according to the Converse theorem. So here we can straight away write down AB is equal to AQ. Now we'll look at the miscellaneous exercise in your textbook. So here they have given information about a circle. So we'll take a circle now and we try to mark all these information. A chord of a circle lies 8 centimeter from the center. So here when you want to mark this, so here we'll take, this is the chord. So this is 8 centimeter from the center. So if the center is this, so this perpendicular distance is given 8 centimeters. If the length of the chord is 12, so this whole length is 12 centimeters when you look at this length, and find the radius of the circle. Now, according to the Converse theorem, when you draw a line, perpendicular line from the center to the chord bisects each other. So what can you say about this chord? If we put AB as the chord, we can say, we'll put C here. AC length is equal to CB according to the Converse theorem. Now, when you look at this triangle now, so here full length is 12 for AB. So what is the length AC? Half of 12, that's 6 centimeters. And when you look at the triangle AOC triangle, we know this is 6 centimeters for AC and this is 8 centimeters. So this is OA is the radius of the circle. So you want to find out the radius. So use the Pythagoras theorem. The hypotenuse squared is equal to the square term, sum of square terms of the other two sides. So 8 squared is 64, 6 squared is 36, and when you take the square root of that, you get 10 centimeters. So what's the radius of this circle here? So the radius is 10 centimeters. Now we'll look at the second question. So here in this question, it's given the radius of a circle with center O is 5 centimeters. So here, how can I mark this? I can mark this distance. OA is the radius that's given 5 centimeters. And the length of the chords AB and BC are 6 and 8. AB 6 and these two lengths are equal means this is 3 and this is 3 because it's already given. So this length is 8. So when you divide by 2, we know this is 4 and this is 4. The midpoints of the chords are X and Y. So that's what it says, equally divided. Find the perimeter of the quadrilateral OXBY. So you need to find out the perimeter of this. So we'll try to find out. Now, according to Theorem 1, when you join the center and the midpoint of the chord, the two lines are perpendicular. So here, this one and this one perpendicular. So according to theorem number 1, this is perpendicular and this is also perpendicular. So we can write down OX is perpendicular to AB and also so OY is perpendicular to BC. So what can you say? So these two are equal. So we can write CY is equal to BY, that's 4 centimeters. And we can write BX and XA, that's 3 centimeters. Now, we know this is 90 degrees. So what can you say about this diagram? This is a rectangle. So we can write OXBY is a rectangle because the angles inside are, all angles are 90 degrees. So this is a rectangle. So opposite sides are equal. So how can you find out the perimeter of OXBY? We can add these two and multiply by 2. So here 4 and 3 given. 4 plus 3 multiplied by 2. So here 4 plus 3 is 7. 7 times 2. So the perimeter of this rectangle is 14 centimeters. Now we'll look at third question. So in the third question it says the length of the chord AB of the circle with center O is 8 centimeters. So here AB length is given 8 centimeters. The perpendicular drawn from O to chord intersects the chord at X and meets the circle at y. If xy is equal to 3 centimeters, this is 3, find the radius of the circle. So when you look at this diagram, so we'll connect this one OA, that's the radius. So we'll put R here, and also we know OY is also the radius. So if you take this one as radius, so what is this length? R minus 3. Now we'll try to draw the small triangle. When you draw the small triangle, we see this is R and this length is R minus 3. And what about this height? It's given the AB chord length is 8 centimeters. Now according to the Converse theorem, when you draw a perpendicular from the center to the chord bisects. So with this information we can write A to this length is half of 8, so 4 centimeters. So when you look at this triangle, it's a right angle triangle, so you can use Pythagoras theorem to find out R. So according to Pythagoras theorem, the hypotenuse squared is equal to the sum of square terms of the other two lengths. So 4 squared plus R minus 3 squared. Now try to simplify. 4 squared is 16. When you expand brackets, can you remember now? When you expand brackets, what you get? R squared plus square of the last term, that's 9, double of the middle two terms, minus 6R is equal to R squared. Now, can you see? R squared get cancelled out. So here we'll take minus 6R to this side. That becomes plus 6R is 16 plus 9. So what's the answer? 16 plus 9 is 25. 6R is 25. So what's R value? 25 divided by 6. So roughly how much? 6 times 4, 24. 1 over 6 centimeters, because the lengths are given in centimeters. Now we'll look at question number 4. So in question number 4 it says AB is a chord of a circle with center O and the midpoint of the chord is X. So already mark these two lengths are equal. The point C lies on the line drawn from X through the point O. So here this is the line. Prove that AC is equal to BC. AC is equal to, you have to show that to be proved. AC equals BC. Now we'll look at the big triangles AXC triangle and XBC triangle. When you look at this triangle, we know that AX is equal to XB. And also we know this is perpendicular. According to theorem number 1, when you draw a line joining the center and the midpoint of the chord, these two are perpendicular. So here we can say CX A angle is equal to CXB angle. So that's 90 degrees according to theorem 1. And also we know CX is common. So here angle and two sides, side, angle, side. And also we know this angle is the included angle. So this is the included angle to these two lengths. So we can say straight away AXC triangle is congruent to XBC triangle. What's the reason? Side, angle, side. So if these two are congruent, we can straight away write down AC is equal to BC because the corresponding elements are equal. So that's how we can show that AC is equal to BC. Now we'll look at fifth question. So you have given a diagram and it says PQ and PR are two chords, PQ and PR, with center O. The perpendiculars drawn from O to PQ. O to PQ, it's given OX and the other side it's OY. If XR and QY are straight lines, prove that PQ equals PR. So you need to show these two lengths are equal. So to be proved, PQ is equal to PR. Now when you look at these two triangles and see what we can find out, we'll take OXQ triangle and OYR triangle. What you know? We know this is 90 degrees. So here OXQ angle is equal to OYR. It's 90 degrees because it's perpendicular to the chords. And then we know this angle is equal to this angle. Why? What's the reason? Opposite angles are equal. So we can write XOQ is equal to YOR. So the reason is opposite angles. Opposite angles are equal. Now look at these two triangles. We see OQ is equal to OR. What's that? That's the radius. OQ and OR radii. So radii of the same circle. Now according to this angle, and a side, so we can say OXQ triangle is congruent to OYR triangle. What's the reason? This is angle, side. So if these two triangles are congruent, what can you say about the corresponding elements? So we can say opposite to this angle is XQ. XQ is equal to, opposite to this one is YR. So that's corresponding elements. Now, when you double that, what happens? So when you double both sides, 2XQ is equal to 2YR. So here we know if when you draw the perpendicular, the chord bisects each other. So that means this is also same length. If it's this one, this is also same length. Now we found out these also same lengths. So here when you double it, you get PQ. When you double YR, you get PR. So we can see that PQ is equal to PR. Now we'll look at question number 6. So this is also about a circle. So we'll take a circle and try to draw the given information. A chord of length 24 centimeters lies 5 centimeter away from the center of the circle. So this is the center. So there's a chord. We'll take AB and the length is given 24 centimeters and it's away from center means the perpendicular distance is given 5 centimeters. And another chord lies 12 centimeters from the center. Find its length. So here there's another chord 12 centimeters away from the center. So we'll draw another chord somewhere here and this length is given 12 centimeters. And you are asked to find out the length of this chord. So we'll put CD or something. So how can we do that? Now, according to the given information, we know when you draw the perpendicular line, the chord bisects each other. So here, if this is 24, what is this half of this? We'll put C here. Now we'll take another letter M and we'll take N here. So what is the length of AM? That's half of 24. That's 12 centimeters. If you take this triangle, what can you say about this triangle? It's a right angle triangle and one side is 5 centimeters, this side is 12. So we can find out the radius of the circle. So we'll put R here. So how can we find? We can use Pythagoras theorem. So we can use R squared is 5 squared plus 12 squared. And when you simplify, this is 25 plus 144. You get 169. How you find out R? Square root of 169. So what is square root of 169? You get 13 centimeters. So we know the radius of this circle is 13 centimeters. Now we can think about this triangle. This is also radius. So when you take this triangle, NOC triangle, what you know? We know this is 12 and OC. The radius we already found, that's equal to 13 centimeters, and you can find out this length. We'll put X or something. So again, this is a right angle triangle. You can use Pythagoras theorem. So according to Pythagoras theorem, you can write the hypotenuse squared is equal to 12 squared plus x squared. 12 squared is 144. 13 squared is 169. When you take 144 to the next side, you get x squared is equal to 169 minus 144. That's equal to 25. So when you take the square root of 25, you get 5 centimeters. So here we found CN length is 5 centimeters. Now how can we find out the length of CD? We know when you draw a perpendicular from the center to the chord bisects. So that means this length is equal to this length. When you double that, you get the length CD. So how you find out the length CD? Double of CN. So what is CN here? We found that's 5 centimeters. So 2 times 5 centimeter, you get 10 centimeter as the length of the other chord. Now we'll look at question number 7. So question number 7 is also about a circle, and it's given the vertices ABC of the equilateral triangle ABC. So it's given this is an equilateral triangle. That means all sides are equal. So here AB is equal to BC is equal to AC because it's given equilateral triangle. And also, what are the other information given? Center is O. The perpendiculars drawn from O to AB is OX, and when you draw the other perpendicular line, it's OY, and the other one is OZ. Prove that OX is equal to OY is equal to OZ. So you need to prove OX is equal to OY is equal to OZ. Now, when you look at this triangle, equilateral triangle, all these sides are equal now. And also according to the Converse theorem, when you draw the perpendicular line from the center, the chord bisects. So here this length is equal to this length. And also we know all these sides are equal means all these lengths are equal because the chords bisects each other. So here first thing you can write down BC is equal to ZC is equal to all these lengths are equal. So you can write what's the reason? Converse of Theorem 1 about chords. So here when you take all these lengths, we can see that ABC is an equilateral triangle and all these lengths are equal. Now I want to draw a line here and I want to compare these two triangles. So we'll take OZC triangle and OCY triangle. What can you say about these two triangles? So here these lengths are equal and this is a right angle triangle. So here hypotenuse is common. That's a common length. And also we know ZC is equal to CY. That's already done here. So here hypotenuse and one side equal means we can say OZC triangle is congruent to OYC. So congruent triangles, because what's the reason? Right angle triangle, hypotenuse and one side. If these two are equal, the corresponding elements also equal. So I can write OY is equal to OC. Corresponding elements. Now here we found these two are equal. Now if you take other way around, these two triangles, I can prove the same thing. So here if I draw this line, I can show that the two triangles I can write similarly. So I'll write here similarly. Similarly, I can say according to OBX triangle and BZO triangle, I can say OX should equal to OZ. That's also same reason, right angle, hypotenuse and a side. So if you know these two are equal, what can you say? OZ is equal to OY. Again, OZ equals OX. So therefore, I can say OX is equal to OY equals to OZ. Now we'll look at the last question in your textbook. So here again this is about a circle. P, Q and R is our two chords of a circle with center O. The perpendiculars drawn from O to PQ and R is our OX and OY. Already given perpendiculars, and you have to show that PQ squared. So this one, so you need to show PQ squared is minus RS squared is equal to 4OY squared minus 4OX squared. So you need OY, this one, and PQ length and RS. Now I'll draw a triangle here. I'll connect these two lengths. What are those two? I know these are radii. So I can write OQ is equal to OS and I'll put R for that. Those are radii of the same circle. Now when you look at this one, so these are two perpendiculars drawn from the center. According to Converse theorem, what can you say? When you draw a perpendicular from the center to the chord bisects. So that means these two lengths are equal. And also this one, these two lengths are equal. So we can write down XQ is equal to PX as well as RY is equal to YS because Converse theorem. So when you look at XQ, here I can write down using Pythagoras theorem a small equation. When you look at OXQ triangle, what I can write? I can write XQ squared plus XO, we'll write OX squared is equal to R squared. And here XQ is there. What is XQ? Half of PQ. Now why I am using PQ there? Because you have to show this one. In this equation we don't have XQ. So we can't write in terms of XQ. So I need to convert that to PQ. So I can write instead of XQ, that's equal to PQ divided by 2. And I can write OX squared, that's equal to R squared. And I can simplify this. What I get? PQ squared over 2 squared becomes 4 plus OX squared is equal to R squared. I want to multiply the whole thing by 4. So I get PQ squared plus 4 times OX squared is equal to 4R squared. So we'll take this one as first equation. Now we'll take the other triangle. When you take other triangle, OYS triangle, what can you say about this triangle? I can write according to Pythagoras theorem, R squared is equal to OY squared plus ys squared. Again, in the given equation, ys is not there, so I can write in terms of rs. So what can I write? I can write instead of this is equal to rs divided by 2. Then simplify this. I get r squared is oy squared plus r squared over 4. When you square 2, you get 4. Multiply everything by 4. You get 4r squared is equal to 4 oy squared plus r squared. Now, we'll take this one as second equation. Now look at 1 and 2. What you get? You get 4r squared here, 4r squared here. So these two are equal. So I can equate 1 and 2 and write pq squared plus 4ox squared is equal to 4oy squared plus rs squared. Now look at the given one that you have to show. pq square is there here. We can take rs squared to this side. So when I take this one to this side, and we'll move this one to the right hand side. So I can write down pq squared minus rs squared is equal to. So this one write as it is, and I'm moving 4ox squared to the other side, minus 4ox squared. Now see, we got the same thing. So that's how we can prove this. So in this lesson, we learnt about two theorems. So the first theorem says when you join the center and the midpoint of the chord and the line both are perpendicular. And what's the converse theorem we learned? When you draw a perpendicular from the center to the chord bisects. So when you get questions related to chords, make sure that you apply those two theorems.